VLPSos here. This is a video lesson for Python programming. Flow. Pause when you need to practice. The word or concept of flow has a few meanings in programming and computer science, but the most practical is in reference to the order in which the program is executing the individual lines of code. The simplest understanding of flow is that a program starts at the top and executes each line before the one below it. But with loops and functions, decision structures, break and return, as well as other keywords commands, the flow moves all around. Understanding and controlling the flow of a program is essential to sophisticated programs. This example will demonstrate how the flow of a typical program may go, as well as provide a suggested outline for how to organize programs. And the code for a program to serve as an example of the various ways that the flow can change has been already written. I'm going to run this program to show what it produces for the user to see, and then I'm going to step through the program as if I was the computer interpreter and go line by line, and we'll watch the direction of the flow of the program as it moves around and executes the lines. When run, this program produces score, and on a few occasions we press enter to continue and we watch the score go up. The score does not go up by one each time, it seems to jump around. And the printing and value of score happens within this code. So let's take a look at the overall structure of this example program. It's a model or a suggestion for how to organize the programs that you write. At the very top, we import. We're importing random. We're making use of the random module in this program. Generally, you want your imports at the top of the file. One reason for this is because then everything below it will be making use of those functions. So they need to be imported first so that we can use the functions in them later. Also, if we are going back to program files that we wrote, or we're a part of a team of collaborators, at the very top of the file, if we read this code, we would see by the import statements at the top the dependencies of this program, the other files that our program is dependent on. Listing them there makes them easy to see. Moving on with the structure, we can see that we have defined a function, function A, a second one, function B, a third one, function C, and a fourth one called hello. Then at the bottom, with the comment, we have our bootstrap. At the very bottom of the file, after we read in the names of the functions, we have a condition. It's a special condition. If evaluated true, then it will run the code block here. Notice that the code block has two print lines and a call to the function in between them. We can see in our output that the print line begin was the very first thing that the user saw, and the print line done was the last thing that the user saw before the program ended. And those two print lines are here with the call to the hello function in between. This bootstrap condition will evaluate true if we are running this program directly. If we run it from the menu or press F5, then with this file open, then this condition is true. If this file was imported into another program and we wouldn't want it to run automatically, then this condition is false, so it does not execute its code block. So let's talk about the structure and then step through the program as if we are the compiler running this, or the Python language processing this program. I'm going to read these notes about the structure of the code, and then we'll go to those places where we can see what's being talked about. Make note about the structure of this program. Import at the top of the file, like we've pointed out. No code within the main body, only function definitions. And we can see that there were 4 functions defined. This bootstrap, which starts as a condition, and there is no other code, no variables, no prints, no other code besides those 5 pieces, the 4 functions and the bootstrap condition. The bootstrap is at the bottom. The bootstrap called a function that made use of other functions. It was the only one that received input and produced output for the user to see. So the bootstrap code block called a single function, and that single function, hello, makes use of and calls the other functions that were defined. The hello function that was called in the bootstrap is the only one that interacts with the user, meaning it's the only one that prints things for the user to see, and it's the only one that gets input. In this case, it's just the press of an enter key. The other functions are functions of utility. They don't ask for input, they don't print anything, they're a process. These functions A, B, and C are utilities of what we can think of as the main function that controls them, the hello function. This is a good structure for many programs. One function that is called that drives the program, think of it as the engine, and the other functions that are defined help that engine run. The other functions are the parts and pieces of the main program. Last comment. Comments were used to describe the essential functionality of sections of the code. In more professional circumstances, the comments at the beginning of the function can be replaced with docstrings, which may provide information on the use of the function. So we're not using what we call docstrings, but we do have comments at the beginning that briefly describe to the coder what these functions are doing in the context of the larger program. The comments here is for the you do section when we finish going through the flow of this program. These are simply to highlight the lines in which we are adding, or we could subtract from the score variable, so that they're visually highlighted when it is the viewer's turn to practice with this code. We'll get to that later. Okay. I'm going to step through this code from the very top and talk about how the computer is moving around the file, the flow of that movement as the computer compiler reads each line and attempts to respond to the commands of the coder. When a file is run or imported, the computer looks at the top line and begins there. And if there's no other keywords to adjust the flow, and there's no errors in the line that's read, then the computer will execute that line and then go to the next one below it. So when this file is run, we go to the very top. The computer sees it as a comment by reading this symbol and doesn't do anything else. It goes down to the next line. Empty space is similar to a comment. It is recognized as empty and it moves on to the next line. And it keeps doing that with all these comments until it gets down to import. When there is an import, it's like the imported file is run. So we're importing a random file, which means that we're going to another file starting at the top and reading that line by line until the entire file is processed. But we know from previous lessons that files that are written intended to be imported by other files most often just define functions so that they are not doing anything when they're executed as an import. Random is like that. Random has many functions defined within it, similar to this program having defined 4 functions. So when we import it, it is read, and then once it's finished, all of those functions are in the namespace. They're in the memory, recognized and ready to use, ready to be called. And then we come out of that random file and return here to go on to the next line. Our computer then skips over this blank space and reads this line of code. It recognizes it as a definition of a function. It includes the name of that function in the namespace. So if after including function A in the namespace, we use that name, then our computer is going to think, well, that is a function, so I need to look for that function and go there. But while we are reading this and not calling the function, all of this code in the code block is skipped over. Unless we're calling the function, we are not reading the lines inside of it. So the computer skips over the code block of that definition, only reading the name of it, including it in the namespace, and going on to an empty line and then another definition. It includes function B in the namespace, but it skips over all the code that is a part of function B. It does that to function C as well. It does that to the hello function also. It does not read any of this code. It simply includes hello in the namespace. And then it goes down to pass the hello function, reads an empty line, ignores a comment, and gets to this condition. It reads this condition, and if it's evaluated false, then it skips over the code block of that condition and reads comments afterwards. And then finally, we'll end the program. If this condition reads false, the user sees nothing. Only the names of the functions that were defined are remembered in the memory of the computer, in the namespace. But there's nothing to look at. Now this would be good if this program were being imported, because we would want nothing to be done if it was imported. But if we're running this file, this condition here will evaluate to be true. So the flow of the program will then begin at the top of the code block of this condition, and then read the print line and print it to the user, which is how we got this begin to be printed. Then the computer goes on to the next line and reads the name of a function that is recognized because it was previously defined and put in the namespace. The reason why we have our bootstrap at the bottom is because if it's going to call functions, we want those functions to have been read and defined already. So the structure of a program should have the imports at the very top, then the functions that are defined, and then the bootstrap. We know what the hello function, we know that there is a hello function, so this call will then go to the definition of hello, and it will begin at the very top of its code block. It will read this line, recognize it as a comment, and ignore it. And then we'll proceed down to defining a variable, an integer, then defining a variable, and those score and playing are now in the namespace of the hello function. So we have 2 namespaces now. We have the namespace of the main program. In this case, the main program has the name cppex24 flow VLP.py, the name of this file. And then there's the namespace of the hello function. And those namespaces for the most part, do not intersect. So if there is a variable, the names of variables and functions that are defined in hello, then when we're in the hello function, those variables will be recognized and used. But if we are outside of the hello function in another function, then it will be a different namespace, and if we refer to score or playing, the computer won't recognize that those variables exist, and it will probably cause an error. So we need to pass and return in order to use the values between functions, and we'll see that happen. After defining these, the program will go to this comment and ignore it, and then we start a while loop. A while loop is a loop where the flow is literally going in a loop. It's going through the code block and then back up, and every time the flow goes back up to this condition, it tests it again to see if it's true or false. If it's true, it then continues to execute the lines in the code block. If it's false, then it skips over the code block of the while loop and checks the very next line after the code block of the while loop. But playing is a variable recognized in this namespace that has a value of true. So this condition of the while loop evaluates to be true, which means that we start its code block, which is a comment. And then score is a variable that is going to be defined. But since score was already defined up here, this is a reassignment. It's a reassignment to a function call. So the function will then, the flow of the program will go to the function A. Function A has been defined. It's in the namespace of the main program. When we read all of our definitions, the function A was included in the namespace, and it will be recognized, function names will be recognized throughout the program. So we're going to call function A, and we're going to send the current value of score, which is 1, to function A. And the flow of the program then leaves this line and goes to the top of the function that it recognizes. The value that it was sent becomes the value that function A expects. It's the same name variable, it's score. It doesn't have to be. We could switch names of the variables. What matters is the value that we sent then becomes the value of the variable here and is recognized in the namespace of function A. We then execute the code block of function A, which is a comment ignored, and then we have score with a reassignment and an increase. So this is a clever shorthand way of saying the new version of score, or the new value of score, will be equal to the old value of score plus 1. Score is redefined and increased by 1. And then we go to the for loop. A for loop will iterate with an iterating variable, taking the values of all those in the list that is supplied in the order that they're listed. So the range function will produce a list of values, in this case that starts with 0, and then 1, and then 2. Count will not take the value of 3. 3 is the signal to end this iteration, this repeated process. So the flow will start with a count value of 0, and it will execute this code block, which is simply one line, which again increments score. And then it will go back up to the top of the code block and think, our iterating variable was 0, now there's a next value 1, and we'll execute the code block, which increases score. The flow goes back up and considers then the value of 2 and executes the code block for a third time. Then the flow goes back up to the top, and it recognizes that the value of count has reached the last value in the list supplied, which is 3. So the flow does not execute the code block. It skips over it and continues with the rest of the program. So that was a loop. The flow kind of doing a circle. The next line is score is equal to a function call. So we have a redefinition of score again, but first we have a score is going to be redefined, but we're going to go into the function b and also send function b the current value of score. So the flow of the program skips now to function b. And notice that we were in the hello function, and from the hello function we went into the function a, and now we're in function b. When we leave these functions, we're going to back out in the same order. Keeping track of that can be a little challenging, which is the purpose of this program, is to show and give some experience and talk about that happening. So we're in function b now because there was a call to function b that we reached. Function b begins. It does expect a value to be sent. We did send it. It was the value of score, which is, I think it's about 4 or 5 now. And we begin at this code block. Comment is ignored, score is incremented again, and now we are in a decision structure. So the flow of the program will start testing conditions, starting with the if keyword. If this first condition is tested to be true, then we'll execute the code block of that condition. If not, if score is not equal to 9, that condition is false. It'll skip over that code block and see that there is another condition to test. And it will keep testing conditions until it finds one that's true and execute the code block for that condition, and only that condition. If it finds a condition that's true in a decision structure like this with ifs and elifs, then once it executes that code block, it'll skip all others in that decision structure and proceed with the next line. In this case, the score is probably the first time that we call function. The value of score is not 9, nor is it greater than 10, nor is it greater than 20. So it tested all those conditions, ran no code blocks, and reached the end. There is no else for this decision. So no code has been run, and it skips to the return. Return means to end the flow within the function or the loop that it is in now. We are in function B. Return means to escape function B, return to where function B was called. And at the same time, send this value. So there's a value in memory, like a baseball in flight. And we're going to return to the place that called function B, which is up here, and that value is then going to be caught at this place. And what do we do with that value? There is no reason, we don't need to do anything with any values that are returned. But in this case, score is going to be assigned to something that's returned. So this variable catches the value that was returned by function B, and score is reassigned to be that value. Now, function B did modify score. It added 1 here. I don't think it, in this case, in the first call, it didn't do any of the other addition, but function B did modify the score, so score is a new value. And then we continue on from this place. We go to the next line of the code, score is increased. Then we have another condition that's tested. Only if score is equal to 30 will we execute this code block. It's almost like we're not letting the score be equal to 30, because if it is, then we change it. But the first time that we run this function A, our score is not 30, so it skips this line and continues on with this return. So the return again terminates the function, immediately terminates the function or the loop that it's in, and to where the function was called. This is function A, so we have to remember, the computer remembers easily, but we have to remember where we called function A, because we have to return there. And we're sending this value back. We're putting a value in the air. Where does it go? Function A was called here in our hello function, so this is where we return. and there's a value being returned, where does it go? It becomes the value of score, because score was assigned to be something that's returning from a call to function A. Now we're back in our hello function, and we proceed on, and we get this print line. And finally, the user can see some evidence of score having been modified, which is this first print line here. It's been modified. Score began with a value of 1, simply reassigning it to be this function A with all of the complexity that we just reviewed, modified so much that now score has a value of 7, as we can see in the output. And we continue on. We reach a blank line, then a comment, and then a call to function B. So score is going to be reassigned what is going to be returned by function B, if function B returns anything at all. So we go to function B, sending it the value of score. Function B does accept that value and call it score. Remember, it doesn't have to be called the same thing for the passing of a variable to work. So score is in the namespace of function B, and we read and ignore this comment. The next line increments score, and then we're in this decision structure. So we could imagine now, because we just saw the value of score, that at this point the value of score got increased to 8. So none of these conditions, again, are going to be tested as true. It'll skip over all of the code blocks of those conditions and then get back to this return. It returns to where this function was called. Where was it called? In the hello function right here. So this is where we return. The value that was returned then becomes the value that score is going to be assigned. And then we print. We move on to the next line and we print. And we see then our second print line of score, and indeed it was 8. Moving on, we ignore white space, blank space, we ignore the comment, and then we have another reassignment of score. What is going to be returned from calling function C. And again, we send the value of score to function C. Function C is here, and so the flow of our program goes to this function C code block. We read a comment and ignore it. We start another while loop, but only on condition that score is less than 15. Well, we just saw that it was 8, and we haven't modified it since, so this condition will be true. If it's true, then we go into the code block of this while loop. If score is equal to 8, then we will run the code block of this if statement. So let's keep track. We have a code block that is the code block of the function. Within that, we have a code block that's the code block of the while loop. And within that, we have a code block that is the code block of if. So this condition is true because the current value of score is 8. And if that's the case, then score is going to be reassigned a call to function B. So here we send score to function B. We're familiar with function B. We do increment it. This time, this condition is going to test true. So we run its code block and we increase score by 3. So a score value of 9 became 12. And then since we ran the code block of this condition, none of these conditions are even tested. It skips over them to the return line and returns score to where it was called. Where was function B called this time? Right here inside of function C. That value, which is now 12, was assigned to be score. And then we go on and we reach this break line. The keyword break automatically terminates any loop that it's in. We are in a loop. We're in a while loop. So we're going to terminate that while loop. We ignore the condition of the while loop with this keyword. We automatically break out of it, which means that none of the rest of the while loop's code block is executed. We immediately go on to the next line after the while loop's code block. And then we reach the return line. We return to where function C was called and send to it, send the value of score, which is currently 12. We go back to where we called function C, and that value then is assigned to be the new value of score. And we go on to the next line. If score is greater than 30, it's not. So we skip over that, and we would test any other conditions in this decision tree, but there are none, so we get to the else. If you ever get to the else condition in a decision tree, it's because all the previous conditions must have been false. And so this is what we're going to do besides. We're going to ignore a comment line. We're going to then ask the user for input, but there's no variable that assigns the input. This use of input is just to get the user to press enter. We're pausing for the user to be allowed some time to look at the output. So the program is going to wait. It will stop executing lines until it gets the enter pressed. And the user could press keys or anything, but all we care about is that enter, and then we go on to a print line, and we print score, which is this line of code here. And we remembered that score was 12, so printing at 12 confirmed that we must have understood the flow correctly. Now that we have got to the end of the hello code block, this printing here is the last line of the hello function. So we see that we have finished. The hello function hasn't concluded. We're not returning to where the hello function was called because that last line was inside of a loop. So it's inside the code block of a while loop, which means that the flow of the program goes back to the condition of the while loop and test that condition to be true. If it's true, we continue and repeat this entire process. If it's false, then the while loop of the code block is concluded, which means that we go to the next line after the code block of the while loop, and there is no other code in the function. So if we escape the while loop, then we also end the hello function, the code block of the hello function, which means that we return to where the hello function was called. The hello function was called in the bootstrap. So if we return here, then we only have one more line of code. It executes it, prints done for the user, and we can see then that that was the last line before there was nothing else to run. Once we finished with the bootstrap, then the program terminates. We've read all of the lines. We will not exit this while loop until the condition of playing is reassigned to be false. Playing is reassigned to be false here. And playing will only be reassigned to be false on condition that score is greater than or equal to 30. Now that's only going to happen if this while loop, which calls these functions and eventually increases the score, it'll go through the process that we are now familiar with. As soon as score has a value that is 30 or greater, this condition is tested true. It will execute this line, printing U1, then execute this line, which reassigns the value of playing, which means that when we get to the end of the while loop and go back up to test this condition, that's when it's tested to be false. And we end the while loop, which ends the hello function, which puts us down here, which prints done and then ends our program. That may have been a tedious explanation. Understanding the flow of a program is critical to being able to understand what code does and then be able to write code that accomplishes your objectives. And we notice that in the printout of score, we have several values watching that process continue. Now you. You have studied how the code of this program flows. Make a copy of this program so that you can alter and play with it. Find a way to print out only even numbers by changing the lines that add to score to add something different, but changing or adding nothing else to the code. In other words, you want to find a way to alter only the lines that add something to score. And those lines have been flagged with this symbol here. Change only how much is added. You could add 0, or you could add a negative number to subtract from score. Your goal is to understand how this program is flowing so that you understand the changes that can be made, so that when the program is run, you don't get any odd numbers when score is printed. Score can definitely be the value of an odd number, but at the moments that it's printed for the user to see if you can only get even numbers to be printed before the program is finished. Play with it, have fun.